Hey everyone, we're going to take a look at number one in section 5.6. 5.6 is an application of integration looking at the net change in a quantity or function as the integral of the rate of change of that function. So this problem, we have water that flows into an empty reservoir at a rate of this, 1000 plus 260 T liters per hour, where T is measured in hours. What is the quantity of water in the reservoir after 5 hours? So to set this problem up, we're going to let S of T be the amount of water in the reservoir at time T. And then notice then the rate of change of water into this reservoir, right, is 1000 plus 260 T. So that's our derivative, right, of our uh, amount of water in the tank. The rate of change is the derivative of the function s prime of t. Notice s of 0 is equal to 0. Why? Because at time 0, what's the amount of water in the tank? Well, since the tank is empty, it is 0. And that's important to note, and we'll explain why here in a minute. Um, S of 5 is what we're looking for, right? What's the quantity of water in the reservoir after 5 hours? So the way we set this up is the net change. So over the 5 hours, the net change in the net change of water in liters in the reservoir would be S of 5, whatever it is after 5 hours, what we're looking for, minus S of 0, what it is initially. Okay. That's the net change. And that's equal to what? The integral over that same time interval from 0 to 5 of what? The rate of change, right? So the rate of change is the derivative. So this is where we set this up, and now we can do the calculus. Notice that S of 0 was 0, and so this side is just S of 5. Notice if S of 0 was not 0, in other words, if we had said something like water flows into a reservoir that already has, 2,000 liters of water in it, then S of 0 would be 2,000. And when we evaluate this definite integral, right, to solve for S of 5, we would have to add that 2,000, right? Add whatever the initial S of 0 is. So in this case, though, it's 0, and so it's not going to change anything. So using the fundamental theorem of calculus part 1, we can evaluate this. The antiderivative of 1000 plus 260t is 1000t plus 130t squared. Hopefully that's straightforward for you. Plug in the upper limit of 5. Plug in 0. Of course, there I get 0. And I get 1000 times 5, or 5000. 130 times 5 squared is 3250. And we get 8,250. And that is indeed the amount of water, of course, in liters in this reservoir after 5 hours. Okay. Hope this helps.